In this sequence of videos, we're going to discuss graphs of other trigonometric functions. We'll see that a lot of the principles that we've established previously carry over here, but there are some changes to the different trigonometric functions that we'll discuss in this sequence of videos. Let's start out by discussing the tangent function. In order to sketch the graph of the tangent function, we'll make a table of values, and for that we have our unit circle here with the quadrantal and the angles that are halfway between the quadrantal angles. And since we're going to make a table, we're going to have to decide which angles we're going to include in our table. That is, what t-values are we going to include. In order to determine this, it's useful to note where the tangent function is not defined, because remember that tangent of t is equal to the y-coordinate divided by the x-coordinate on the unit circle. So if this x-coordinate is 0, the tangent function is not defined because you cannot divide by 0. And so on the unit circle, there's two places where the x-coordinate is 0. Up top at t equals pi over 2, or pi over 2 plus 2 pi, or pi over 2 minus 2 pi, or any angle which lands you at the top of the unit circle and the bottom part of the unit circle. This fact will influence what t-values we choose to put in our table. Another fact that will influence what t-values we choose is with graphs of previous trigonometric functions, we only graphed one period of that trigonometric function. That's because once you graph one period of, let's say, sine of x, then the graph just repeats itself over and over again. So in some ways, displaying one period gives you information about the entirety of the graph. And to graph one period of sine of t and cosine of t, we needed to graph between 0 and 2 pi. In other words, we needed to get the t-values for one full revolution of the unit circle. What we'll see in this case for tangent of t and later on for cotangent of t is that the amount of time it takes for the graph of tangent of t to start repeating is not 2 pi, but it's pi. For example, if you do tangent of pi over 4, you get positive 1. And so that would be at this point on the unit circle, but if you go around by pi, that is 1/2 of the unit circle, tangent of pi over 4 plus pi, that's tangent of 3 pi over 4, or excuse me, 5 pi over 4, not 3 pi over 4. And when you do the y-coordinate, which is negative root 2 over 2, and divide by the x-coordinate, negative root 2 over 2, again you get 1. And this is true no matter what you pick for this t-value. So whether you pick pi over 4 or pi over 6 or pi over 12, it doesn't matter. If you do tangent of some angle t and then do tangent of some angle t plus pi, you get the same thing. And so the period for tangent of t is pi. So whereas with the sine and cosine function, we needed to sketch the graph on a length of period 2 pi, for the tangent of t function and the cotangent of t function, as we'll see, we only need to sketch the graph on some interval of length pi. And visually, in terms of the in terms of the unit circle, that means we only need to make a table for 1/2 of the unit circle, because 1/2 of the unit circle has circumference pi. Now the standard choice for creating a table and sketching the graph of tangent of t, the standard choice for the t-values is to record the t-values and the tangent of those t-values on the right half of the unit circle. And there's a good reason for this. The reason is that 1, this will graph one period, as I just discussed before, and 2, it sketches one period that's between the 2 points where tangent of t is not defined. So this is where we'll be looking, the right half of this unit circle, when we go to create a table of values for the tangent function. With a small point here that we'll need to change a little bit. For these t values on the lower right hand side here in quadrant 4, we have 7 pi over 4. And then when we cross over the t values that we listed, we have pi over 4. It's much more natural to create a table of values when we use t values that are negative in the lower right hand quadrant, the quadrant 4. The reason being, if you imagine making your table right now, you would have some t values, some angles, and then tangent of t. And what would you be filling in for t? Well, if you start at the bottom here, where tangent is not defined, it would say something like 3 pi over 2, then 7 pi over 4, and then 0, because we have 3 pi over 2, then 7 pi over 4, then 0, then pi over 4, then pi over 2. And it's a bit strange, right, to say 3 pi over 2, 7 pi over 4, and then 0. So what we'll do is we'll replace 7 pi over 4 with a negative coterminal angle, which is 7 pi over 4 minus 2 pi, and that ends up being minus pi over 4. And we'll replace this 3 pi over 2 with minus pi over 2. This is much more natural. We go in sort of a from smallest to largest here, instead of getting larger, 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 and then resetting at 0, and then getting larger again. So let's fill in our table here and sketch the graph of what tangent of t looks like. So if I needed to do tangent of minus pi over 2, that's undefined. So there's nothing you can put right here. And to show you why it's undefined, again, remember tangent of minus pi over 2, that's the y over the x coordinate. And let's go ahead and fill these in with their coterminal negative versions. So negative pi over 4 and t equals minus pi over 2. And at minus pi over 2, we do the y coordinate, which is negative 1, divided by the x coordinate, which is 0. So negative 1 divided by 0, which is undefined. And we'll see here that what happens is we have an asymptote at negative pi over 2, much like the rational function, for example, 1 over x minus 1 has an asymptote when x equals 1. This is a fact that is learned in previous classes. So I'll put UND for undefined, and we'll talk a little bit about this in a moment. And now let's evaluate tangent of minus pi over 4. So if I look back to my unit circle, I see the y coordinate is negative root 2 over 2, and the x coordinate is the same but positive. So that means if you divide these two, you get negative 1. So negative root 2 over 2 divided by root 2 over 2, you get 1. Of course, with a negative sign, so negative 1. So this is negative 1. Let's evaluate tangent of 0 and tangent of pi quickly. So tangent of 0, you take the y coordinate of 0, divide by the x coordinate of 1, you get 0. So 0, and then at pi over 4, the y and the x coordinate are the same, so when you divide them, you get 1. And then finally, at pi over 2, as we said before, the y coordinate is 0, the x coordinate, or excuse me, the y coordinate is 1, the x coordinate is 0. 1 divided by 0 is undefined. And similarly to the graphs of sine of t and cosine of t, I'm not filling in the t values for pi over 6 and pi over 3. I encourage you to check any standard text to see the table values for those as well. So now let's go ahead and start sketching our tangent function, and let's include these y values. And then we'll talk about the undefined, or the part of the graph that's undefined, in a moment. So we'll need some axes. We'll set up t and y axes here. I'm going to make my scaling so that this here is pi over 4, so that this would be pi over 2. Here we have minus pi over 4. Here we have minus pi over 2. And when I actually graph this function, it's nice to have this marker above actually the t-axis. And then for my y scaling, I'm going to make this positive 1, and thus that would make this negative 1. So we can fill in those three y values at minus pi over 4, 0, and pi over 4. So at minus pi over 4, the y value is negative 1. At pi over 4, the value is positive 1, and at 0, it's 0. And we haven't filled enough points in to see exactly how the function behaves between these 3 points that I've drawn. Does it go like this? The answer is no. The behavior that it has is it curves, and it looks something like this. Again, feel free to take a look at a picture of any standard pre-calculus text to see a bit of a more detailed drawing on why that's the case. Now let's talk about what's going to be the behavior of the graph between pi over 2 and pi over 4, that is this area here, and between minus pi over 2 and minus pi over 4. So this area between pi over 4 and pi over 2 on the unit circle would be the area between here and here. So between pi over 4 and between pi over 2. And if you imagine some angle with a terminal point on this part of the unit circle that's really close to pi over 2, so x comma y, then for this terminal point here, y would be very close to 0, it'd be very close to 1. And that's because, of course, at pi over 2, the y value is 1, and the x value is very, very close to 0, because the x value at pi over 2 is 0. So when you take this y value and divide it by this x value, you get something very, very large. Very, very large and positive. You can check that for yourself. Just take some examples. If you do something like 0.999 divided by 0.001, you get a very, very large number. That is, if you take something very close to 1, divide by something very close to 0, you get something very large. And so when you do tangent of an angle that's very close to pi over 2, you get something very large, because tangent of an angle is the y coordinate over the x coordinate. And so in order to indicate that tangent of t gets extremely large, we will go ahead and draw a vertical dashed line at pi over 2 to indicate that there's an asymptote, that is, to indicate that the y values are getting extremely large as we get close to that x value, or perhaps t value of pi over 2. And so our graph is going to look something like this to indicate that the y values get extremely, and in fact unboundedly large, as the t values get close to pi over 2. Now, what about as the t-values get close to minus pi over 2? Well, it might not be so hard to convince you after I've convinced you that the y-values get really, really large as t goes to pi over 2, that the y-values get extremely small as they go to minus pi over 2. And by small here, I mean very, very negative. So a very small number is like minus 1 billion, not a number that's close to 0. And so to indicate that, I'll need to scroll down a little bit for my drawing. I'm going to draw my vertical dotted line, and I'll go ahead and draw my y-values. Oh, I need to turn off this line feature. This y-value is getting really, really negative. And this would be a sketch of tangent of t on one period. And just like there are important t-values and important y-values for cosine of t and sine of t, there's important t-values and y-values for tangent of t, namely the ones that I've filled in here. These 3 points for negative pi over 4, 0, and pi over 4 with y-values minus 1, 0, and 1. And then the 2 other important t-values have asymptotes.